All right. Well, we're going to start up by setting up a project just like you would normally inside SolidCAM. So I'm going to simply start a new project by going to New, Milling. Now, all this is the same as if you're doing any other kind of milling inside SolidCAM. I'm going to grab my CNC machine that I'm going to use. I'm going to grab a coordinate system. I'm just going to place it right at the top of this one. Puts it down here in the corner, that's fine. Now we're going to go ahead and define our stock and our target so we can use Solid Verify. And I will use 3D model since I have one. And for our target, obviously it's our part that we want to make. So we'll grab that. Now, if you know you're going to go into iMachining, you can go ahead and come down here and start filling out this information, especially if you've already created a machine. If you haven't created a machine, that's what we're going to do now. We're going to define a machine and define a material that we're going to be used to cut this particular job. So if you haven't defined this and you don't define it now, the first time you go into iMachining, it will ask you to define this because we base our feeds and speeds that we recommend to you off of the tool, the size of the tool, the helix of the tool, the length of the cutting flutes, as well as the machine that you're cutting on and the material. So those three factors are what we get the feeds and speeds from. So we'll go ahead and go into Edit Machine, iMachining Database. First thing you're going to see is a machine and then, of course, materials. Now, I've already have one in here, but if we wanted to define a new one, I'll just call this a POS VF2 SS, and you'll have to do this per machine. You only have to do this one time per machine, so once they're defined, you can just simply grab it from the drop-down list. But you want to be accurate with the values here. If you know the machine can do 12,000, if that's its max spindle speed, then you need to put that in. If you don't, we won't be able to give you accurate feeds and speeds. Now, you may be saying to yourself, I don't want to go to 12,000 ever. Well, you don't have to because you have a machining level. You have an aggressiveness that you can choose, but you still want to be accurate with the values here. Feed rate, max feed rate on this machine is 833. If you don't know the maximum repositioning feed rate of the machine, it will default, or if you don't put one in, it'll default to the max feed rate. But I would be accurate about that, so find out what they are. This one does 1400. And of course, I believe this is rated at 19.9 horsepower, and it's a direct drive. So I'm going to go ahead and select material, and we'll go ahead and choose aluminum on this. And we'll do a save and exit. We can come back and look at that in a little bit. So I've defined a machine and a material. Okay, it's something I've created. I've already defined the machine for here, so I'm going to go ahead and grab that from the drop-down list. And this is just a default, so if we didn't have to go into that definition of the machine, you could actually just grab your material from here. And your machining level is already set at 3, which is the default. But you can up that if you'd like. I'm going to go ahead and leave it 3 and go ahead and finish. Again, if you don't do that on that first definition screen, that CAM part definition screen, the very first time you go into iMachining, it's going to ask you to define those parameters that we just did. So we do have 3D iMachining, but we're not going to be showing that today. We're going to be doing just 2D. So I'm going to go ahead and go into iMachining right here. The dialog pretty much looks the same as any other dialog, whether you're doing 2 through 5 axis, mill turn, turning. Our workflow is still here. Still start at the top, work your way down. Everything changes when you get into Technology Wizard here, however. So let's start off by that we definitely want to do an iRough. We can come back and do a rest machining. That's in case you have a bigger tool you want to rough out with and there's material left in areas that the bigger tool couldn't cut. You can come back in and do a rest machining operation, and maybe we'll go ahead and take a look at that. And of course, you can do a finishing operation. But starting with the rough, we're going to define our geometry. Geometry is defined exactly the same way you would in any other operation. Since I have a stock box and I have a part, I'm going to start, and I'm cutting on the outside of the part, I'm going to start with defining my stock. Now that the stock is defined, I'm going to tell it that this is actually an open edge. This red boundary is saying that the tool has to stay inside the red boundary. But what I'm going to say is right-click on the chain. I'm going to mark the entire chain as open. Changes the color. Now it says, well, I know where my stock is, but the tool is allowed to start in the air and work its way in. So you want to define your stock first when working from the outside. Now I want to define my actual part, and I'm going to chain that around as well. And that one is going to stay red because I want it to be the actual hard boundary. I don't want to cross over. So the material between the red and the black is what I want to cut. And we could go ahead and say rough OD. Tools. Want to be accurate about your tool. What's the length of this? We have approximately 1 inch 10 plus a little bit of a fillet. So it's over a 1 inch cut length. So we just got to keep that in mind. I'm going to go ahead and grab, I guess, an end mill for the outside. And we'll call it a 1/2 inch. Now down here we only have a 1 inch cut length. This very much matters because iMachining will not take it any further than what the cut length will be. So if this is over an inch, it'll have to be done in 2 steps if you don't have the cutting length. So I want to make sure I can do all of it. So I'm just going to take this up to 250. And I'm going to take this up a little bit too there. And we'll make this 2. And make 4 flutes because I prefer to have 4 flutes on here. Now, instead of having to go to tool data, which is where you would normally have set up your feeds and speeds, you don't have to do that. But I do want to show you the iData tab. The aluminum is then chosen for us because that's what we selected. Your default is 3. Of course, you can change that here. You can also change your max chip thickness, how much you want to take. But this is the carbide material of the tool as well as the helix angle that you bought. Okay? So these parameters do matter on the feeds and speeds that we choose for you. I'm going to go ahead and select that. Nothing I really had to do in there. I just want to show you what was in there. Levels. Levels are still chosen the same way. I'm going to start at the top here. And I'm going to work down to the very bottom here. And maybe I'll even give it just a little bit of a push through to make sure that we get past the outside a little bit more. Oh, it's already at 250. See, this is a good thing to show. Pocket depth all the way from the outside here, if I take a look at this, is 1/250. So my cutter will have to do it in 2 passes if I want to go an extra 50. And I do, so I actually am going to change my cutter to give myself a little more length. Oops. Let's pull that over here, and we'll do 1.5 there. That's fine. All right. Inside the Technology Wizard, normally this is where you'd be setting your side step over, whether it's a contour or a hatch style pocketing, all kinds of parameters, whether it's a rest machining operation, your how much material you're going to leave on the sides, the floors, the islands, whether you're going to finish in the same toolpath. That's typically what's down in this area. However, in here, you only have to look at one thing, and that's your machining level aggressiveness. How hard do you want to push this tool? Right now, it's defaulted to 3. You have 2 different views to look at. View 1 is your RPM, your inch per minute, and your side step over, which is traditional to most machining. But you'll notice that you have a max step over and your minimum step over. In view 2, you have feet per minute and your chip thickness, and then of course a cutting angle, which is what we use to manage the tool's engagement in the material all the time. It'll never fall below 14, and it'll never exceed 37.7. If you change the slider, starting at 1, these values, all these values will change up to level 5, I believe, right there. And then once you get to 6, 7, and 8, it just changes the feed rate and the chip thickness. Okay, so you could choose which view you want, but this is actually the view that we're actually paying attention to right here. Of course, these are just some values that equal to view number 2. Inside the box here, you might have this panel right here read yellow, red, or green. That's basically just telling you that you are good or not good on the axial contact points. That's how many flutes are engaged in the material at any one time. You can affect this by using a user-defined. You can use step downs, or you can do a number of steps. I don't recommend doing any of that. If you're trying to bulk material remove, then go ahead and leave it where it's at. You're likely going to be deep enough. But if you're on a shallow part, well, you're going to see probably yellow or even red. However, just keep this in mind. It's not super critical, the color-wise. 3.3 is an awesome number to have. That's saying that technically 0.5 is 1 flute in the tooth, or in the material at all times. So if you have a 1 here, you have 2 teeth in there at all times. 3.3 is excellent. Even though it's only showing yellow, it probably should show green. That's actually a very good sign, because the vibration of your tool is going to be cut down. The machine will run quieter. Your tool will last longer. This has all been already been proven out, but it's just a quick denotation so you can look at and say, yeah, it should run really well. At level 3, let's see what we got at level 8. See, it does not go all the way up to 12,000. That's why I was saying you don't have to worry about it. If you never even wanted to approach that even close to it, you can back it off to where you want. Most people start out here. Everybody I've ever talked to eventually make it up to level 8 because they all run very, very well. Now, even at level 3, you're going to be cutting faster and better than you ever would with any other traditional style toolpath. But I'm going to go ahead and crank this up to 8, and I'm going to simply say, well, before I save and calculate, let's go into technology real quick. Because this is a rough, it's automatically putting 10 thousandths on the wall for you. You can add more here, and you can put some floor offset in here as well if you don't want to go all the way down to the floor. Okay? In here I do. I'm going to go past this, so in my levels I actually put in a negative 50 thousandths. So let's go ahead and save and calculate this now. And I'm going to go ahead and check mark that, and we'll go ahead and take a look at this. That is an iMachining toolpath that looks quite a bit different than a standard traditional toolpath. Let's go ahead into simulation real quick into Solid Verify, and we'll take a look at how this will cut. And let's go about there. Always managing the tool's engagement. It's going to take off the material where it needs first so that it can get into more of a race tracking style, which is basically a spiral toolpath. That's what you're looking for. Now, if we turn on our show data, we can find out how long that took to run. 1 minute, 21 seconds. Real close to that, give or take a second or two. And we can play that again. You can see that as it seems crazy, but it's very true. The only way to really believe it is to run it on your machine, and we would be more than happy to help you do that. All right, so that's with iMachining, and why I showed this first is I wanted to show you that you do need a closed loop with iMachining, or closed loops. It doesn't work with just a simple line. We need to have a closed loop. Now that closed loop can look like this. Let's do another one in this area right here. We'll start another iMachining toolpath. Actually, before we do that, let's do this. We're already roughing, right? And let's say we want to throw a finished toolpath on here real quick for the outside. Very easy to do. I'm just simply going to do a save and copy, and I'm going to change it down to iFinish. That's it. Save and calculate, and it's done for me. So, although this one, I need to recalculate real quick. Seems to happen on the first one. I don't know why that is. Anyway, we'll go into simulation, It's going to calculate what the rough looked like already, and we'll go ahead and play. That was a little fast. Let me play it again. Now that happened because what I did, simply by dropping it down to iFinish, if we go into technology, you'll notice that the island's been taken out, the floor or the wall slash island has been taken out, and it simply threw in a finished toolpath. So you literally didn't have to do anything other than make a drop down. All the other parameters are the same. Now, as far as the other open pocket, like I said, we do need a complete chain. So, excuse me, we're going to go ahead and create another cutout here on this pocket with a closed loop, but we'll mark part of the chain as open. So I'll start up here. We'll work our way around. We'll come down right to here. Now that's a closed loop. That's what I want to cut. Except now I'm going to say mark open edges of the chain. Go ahead and select this, this, and that, so it knows that the material stops here, and this is the actual edge of the part. And I could probably choose that as black too, but it's not necessary. And we'll call this open pocket. I could use the same tool, but since we have a radius down here of 60 thousandths, we'll go ahead and create a new bullnose tool. I'll still make it a 1/2 inch. Oops. Just an FYI, this description field is verbatim text, so you can type whatever you want, wing, ding, special characters, and it can be output in the code. And let's do 1.5, 1.5, and 4. All right. Again, our levels, I'm going to start there, and my pocket depth is here. Technology Wizard, I'm just going to crank that up. Notice it is now green. It's green because it fell directly on a whole number. That's when it shows up green. Fact is we have we're going to have 4 flutes in the material at all times, which is an incredible. That's what you want. So we'll go ahead and save and calculate. And let's go ahead and take a look at this in simulation. Slow it down and play it. You can literally program your entire part with iMachining. You can even do holes. You can interpolate holes if you had to. Generally, you're going to drill holes, but I have done some testing in the past where we compared helicaling out holes versus drilling them, and we could actually beat it. So let's zoom up and do that again. Watch the tool's engagement here. Right here, if we zoom up, from this point to the center of the cutter, out to this point, that's the tool engagement that we're referring to. That's what that tool engagement is talking about. How much of the material the tool is in at all times. And that varies a little bit, but it never goes above the max and it never drops below the minimum. All right. All right. Let's go ahead and create a rough for the inside here. Now, because we're working on the inside of the part, the chains have to be opposite. Normally, when you're working from the outside in, you always start with the open edge pocket first, and then the closed edge. But when you're working on the inside of the part, you need to start with the closed edge and then the open edge. So what we'll do is we'll create a new iMachining toolpath. This time we're going to define the open edge here. Oops, that's not what I want to do. And actually, I want to give it a name. Forgot to name it, so what I'm going to do is just simply take that out. All right, so define the open or the actual part edge first. Don't do that again, Darren. And then define the open edge. Actually, I want to reverse that. And I'm going to mark the whole edge as open. And we'll call that rough ID. Tool, we use the same tool, bullnose. Levels, again, are going to be upper level. Pocket depth is going to be down here. And of course, my technology wizard knows it. Notice how it keeps dropping to that 3. That's because what we've set as a default. At any point, you can change that. I'm going to crank it back up, and I'm going to save and calculate. And if I did that right, we should get a good tool path, which we did. And we'll turn that down a little bit and let it run. Now, this is assuming that that material in the center has been cut out. That's why it's going to start where it starts. We're assuming that this material is already gone. There's no reason to cut all that out again. Now, of course, if you had to cut that material out, you just simply don't define an open edge right here. All right. If you want to get into a hole and you don't want to helix down, like this one didn't helix down because we had an open edge. Let's go ahead and make with any other pocket. So far, all of ours have been open edges. So we'll go ahead and create, I don't know, let's do this pocket here. Even though it has a hole in it, no big deal. iMachining, and we're going to define a closed pocket here, loop. So we'll go ahead and chain that all the way around. Oops, I didn't select it, did I? Here we go. And tool, bullnose is fine. Actually, no, we'll go ahead and go with that for now. I can show you something later here. Upper level, obviously the same place, and pocket depth down here. Just grab my level, and you're going to notice that it's going to generate a helix in the pocket. All the other stuff that we've done so far has started from the outside, so it can plunge straight down and work its way in. There's no need for this helix into the pocket. Okay, but let's say you didn't want a helix into this pocket. You actually want to drill a hole and then feed down there. Well, you could do it similar to this. If the hole was already there, you can go ahead and select the inside edge as that open pocket just like you would here. However, let's go ahead and drill a hole first on one of these other pockets. We'll do this one. I'll say add drilling operation, if I can find it. There it is. We're going to drill this hole right there. And I'm going to grab a tool. Instead, I know that's kind of a big hole, but I'm just going to go ahead and grab a tool that's the size of that hole. So what I'm going to do is put my cursor in the drill diameter, simply select that edge. It's that size of a hole, and that's fine. We'll do 5, 2. All right. Levels, upper level, we start here. And depth, we're going to go to the bottom of the part. Actually, bottom of the material. How's that? With a little bit, we're going to go full diameter and do maybe a 50th thou push through. And that's fine. Save and calculate. So let's do a quick simulate, make sure we have a hole that goes through this part. And it's wanting to calculate. It's probably calculating the helical down right now. That's what takes a little bit of time. All right, so there's our pocket, and we will drill a hole, and there's our hole. Now that we have a drill sequence in there, if we go to iMachining and we want to use a previously drilled hole instead of a helix, we're still going to define our pocket. So we'll define it over here, just like we've done with all the rest. Grab the same tool, levels again, upper level, pocket depth. But instead of simply coming in here and cranking this up, which we could do, and we could generate a toolpath that's going to look identical to the one over on the other side. But this time, we actually want to do a pre-drill. Any drilling operations that come before this toolpath are automatically going to be put into the list. They don't have to be directly in top. This one could be all the way up here. It doesn't matter. The fact is, any drilling operations that come before it are going to be put in the list. So I'm just going to grab that. That's in your links, and I'm going to save and calculate. And now you have a toolpath that's going to plunge down in the open area of that drilled opening and work its way into the material just like you did in this area. All right, now what if we had or wanted to generate a path that's using a bigger tool to cut the majority of the material out of there, such as something like this here, and then come back in and do some rest machining? Well, we can do that as well. Go into iMachining. And so far, I've only been picking one or two paths. You can do multiple pockets simply by doing multiple chains, and I'll show that as well. We'll go ahead and define here, and we'll define this pocket, and I'll chain that all the way around. That's the one I want to cut. And let's do this one at the same time. We'll grab this edge and chain that one all the way around. So we're cutting two pockets at the same time. We'll say of course, they would need to be at the same depth. Got to keep that in mind. Excuse me. This right here is a 270, so a ½ inch would easily cut that. So let's go ahead and put in, I don't know, a 750 cutter. We'll use a bullnose. By the way, that little symbol is holding down the Alt key and using the number pad, not the numbers above your QWERTY keyboard. Hold down the Alt key and type in 0216. There's different values you can do, like hold down the Alt key and hit 248. You get the degree symbol. Just in case you guys are wondering, this is a 750 bullnose, so 750, and that was, what did I say, 60, not 60, or 60 inches, that'd be 60 thou. Okay, we'll call 4, 3, 2, 1.5, and 4 is fine. Levels, again, upper level, pocket depth. By the way, the upper level defines how high your helix is. So if you define down here, let's say you only had a little bit to take out, define the upper level here and you would get a shorter helix. Technology Wizard, we'll crank that up, and we'll go ahead and calculate this out. Let's go ahead and turn the toolpath on so we can see it. As you can see, we have two different toolpaths. Let's go in there and run this. And what we'll do is, after we're done running it, it's taken 38 seconds. This is not accurate on the helix. Or maybe it is. I think there's an actual feed rate that you can change on this one for the helix. So we're using a 750 cutter. We're going to have more material in the corner here. So if we use our As soon as this is done, turn this out of the way. If I hit rest machining, well, because this is a rough operation, this is all red. So what I'm going to do is I'm going to come into here and execute that. Now you can see clearer what we have left over. In the corners, you're showing that it's between 10 thousandths and 100 thousandths. You know you have material left over. Okay. Also, from 0 to 10 thousandths is blue. This was just roughing. We never finished these, so there is 10 thousandths on those walls. The yellow is down to depth because we went down to depth on all the floors. And I did a finish cut on the outside as well. Now this looks a little blue only because of the faceting. If you wanted to get a little more accurate with that, you could take this down to, say, 2 thousandths, execute it again, and it's probably still going to be blue, or it's going to alternate, and that's because of the accuracy settings in here. You can crank this down as well, and you can keep cranking it down. You can play with all these numbers and stuff. But the fact is we do have material left over in this corner, so, oops, I like that. That'll work. And select OK. Turn that off. So we need to get out that material just out of the corners. So I'm going to take this operation, because everything I want, I'm going to do a save and copy on that as well. And I'm going to do a rest machining operation. So geometry is still picked for me, tools still picked for me, levels are still picked. There's nothing I have to do. I'm just turning it into a rest operation, except that that's the old size of the tool. I need to put in a smaller tool, obviously, so we'll put in a 1/2 inch instead. Everything else, though, should be set for me, except for that default. Save and calculate. And let's turn that on. Recalculate that real quick. There's the tool path that's going to come in here. Now, if you didn't want to take, if you wanted to, this is aluminum, so it could easily do that. However, it's only showing a couple paths in here. If you wanted to see more of the paths, or you're worried about the tool, well, looks like it's going to do it anyway because it knows it can take all that material. I was hoping to just put in that. Yeah, there's a couple extra lines there for you. It does its picking in the corner where necessary, just to get the material out. Now, if I'd used maybe a bigger roughing tool, we'd probably see a little more paths in there, but let's go ahead and go into simulation. Because I recalculated this one here, it's going back through and making sure that we're going to be updated according to the stock where we're at all times. So I'll give this a moment. That's that helical. Solid Verify is very technically accurate. It really does its best job trying to show you what it truly looks like based on the tolerance settings and the facet settings that you choose. The reason you're seeing that is it's doing a calculation, but if you rotate the screen, you'll actually see the progress of the tool. All right, that's cranked out. We've got one more to do, and then we can go in and do the rest machining for both pockets. Now, it would go a little bit faster, but that bull nose that we chose, like I said, the system is trying to accurately display what it actually looks like when it's cutting. So that one should just be about done. And now we can go into our finishing or our rest. Let me slow this down. That's taken off 5 thousandths off the wall because rest automatically takes a little extra off the wall. We dropped it down to 5. That's why you see the first pass. then it comes back in and it whittles out those corners. Now you'd still need to do a finishing toolpath on this as well, or you could take out that 5/1000 that it's leaving when it's doing the rest and just have it go ahead and finish. All right, and of course, finishing toolpath to be a save and copy. Change it over to rest or to finish, sorry. Save and calculate, and you're done. Technology Wizard should still be there, good. And that is our finished toolpath. All right, let's see. Anything else I need to talk about in here? No, I think I pretty much covered everything that I need to go over. So I'm going to open up this to questions. Actually, before we do that, I do want to say one thing, a couple things here. I talked about going back to the material to manipulating this. Let's say in any one of these, let's just take a look at this real quick. Let's say that you want to max this out. You want to go to 12,000 because you've noticed that it cuts great at 3, 4, 5, 6, 7. You're already up to 8, and it's cutting great, which I know you will be happy with, and you will get to 8. And you're going to ask me, well, how do I make it go faster? Well, there's a couple ways. There's actually quite a few ways. One of them is you can turn on an advanced setting, but before we do that, I'm going to show you that inside the actual material, and there's a couple ways to do this as well, inside the material that you're using, you can switch on turbo mode, okay? This is one place to turn it on when you're in here. The other place is to open up the settings, go to iMachining, and turn on your advanced cutting condition. As soon as the advanced cutting condition is on, when you go into your iMachining Technology Wizard, you're going to have another tab right up here. This is going to be where you can set all your feeds and your speeds independently if you want. But here's turbo mode. So if we go ahead and turn that on and we go back to cutting condition, you'll now see that the RPM is up to 12,000 and everything's been adjusted from here to there. Now maybe you're already running here and we do have people that have already made it up to 8. We've turned on turbo mode and they're loving the way it's sounding and running. They're going to come in and say, well, you know what? I want to go faster. Now, this is maxed out on my machine, but I can turn up my chip thickness if I wanted to, so I could take a bigger chunk. Okay. The other place that we saw that chip thickness was inside the tool iData tab right here, where you can give it a chip control. You can minimize it or maximize it here. So, oh yeah, save. Now, normally I wouldn't show this because I don't think you should turn it on right away. I think you should work with what we give you first until you get comfortable with it. Then you can go ahead and come in here, and you don't even have to turn this on. You can turn this turbo mode on from the material that we talked about a little bit earlier without having to look at all this stuff, okay? You could also actually turn on turbo mode, and then simply turn the thing back off again. I believe you should still be in turbo mode, so you don't have that extra tab inside iMachining. But, yep, it does turn it off. So you would have to go to the material for that, and we could go into here and turn it on. Material, turbo mode, on. Okay? I don't want to leave mine on right now, so I use that all the time. Inside, there is a technology. We briefly came in here, showed you that in roughing it's going to be 10,000ths. With rest, it's going to be 5,000ths, and then with finish, it's going to be nothing. Of course, in rest, if you want, you can say 10. You can put 10 there if you want. All right. But inside the technology, there's a few other things here. You have a morphing spiral control, and you have an efficiency rate. The best way to use these is it's going to vary on most parts. We put it at levels that we think are going to work best for most parts, but it's not a bad idea, especially like on a face or a part where you have an open edges or something like that. I would try cranking this all the way down to 1, running the toolpath, checking the time, then cranking it all the way up, and doing the same thing. Run the toolpath, check the time, and take a look at it. Then you'll know what works best on that particular part. That's the best way to really see exactly how this affects your part. The entry rate, it just gives you a longer or less entry rate. Again, depends on what you're doing. I have messed with these, and it has sped up my entry rates, which actually decreased my cycle time. So they are in good spots. In the beginning, I wouldn't worry about this, but again, this is all for a little more advanced stuff. Once you get really comfortable with it, you're already running at level 8, and you're like, hey, let's see what else I can get out of this. Of course, you can finish the floor with iMachining. Personally, I recommend using a traditional toolpath for finishing, and here's why. If we turn on the toolpath, you'll notice that you've got, this is tool engagement. It's engagement controlled machining. So we're managing the engagement. But we're doing that because we're taking this full length of cut here. We're no longer cutting down in 1/4 inch increments or 800 thousandths or whatever, because we can. And that's why we can cut so much faster, because we're engaging only a certain amount of material. Now, but because of that, technically, with finishing, if you're only taking 10 thousandths on the floor, you're not worried about engagement. Just go ahead and cut. You can do a 75% step over. You don't have to worry about engagement. So yes, you could finish with iMachining, and maybe on a small floor it's no big deal. But if you're doing a lot of parts or something like that, I still recommend a traditional pocket for finishing the floors, which is why we'll never get rid of pocket or anything like that. We don't plan on getting rid of any of our toolpaths we've already created, but we do think that iMachining is probably, in 90% of the cases, the way that you should machine. So we have some questions. Let's go ahead and take a look at some of these. All right, John, how do I get the diameter symbol? Okay. That is, and hopefully this goes out to everybody, holding down the Alt key plus the on the number pad, not the numbers above your QWERTY keyboard. It has to be a number pad. You're going to type in 0216. Okay, whoops, 0216. Okay, for send to all. For the, did you guys get that? I don't know if you got that. I don't see my, oh, there it is. There's my answer. Okay, for the degree symbol, it's the Alt key plus 248. Okay, send to all. All right. This is Greg. When I finish, can you have it do 2 passes? Good question. I've never actually done 2 passes, but let's take a look at it. I finish. Levels technology. I would think it'd be in here. We can do wall finish, total depth, and we can turn on compensation. But I am not seeing dose passes here. It looks like no at this moment, Greg. I will talk to Chris about that and find out if I'm missing something or if they just haven't put it in yet. But it looks like only 1 pass for now. All right. How does this differ from HSM in 5-axis positioning, 3-axis machining? Okay. Can iMachining be used this way? We machine turbine wheels with exotic blade surfaces. Seems to be for swarf cutting at full depth. 3 places that iMachining shine, and we can do it in 3D as well. The next release is going to have 3D iMachining. We can also wrap this iMachining around a 4th axis, so you can actually do this. You can actually wrap this. I've done that. It works very well. the thing about iMachining is it shines in 3 places. It's made for bulk material removal, exotic materials, or really small tools. Because we're managing the tools engagement, small tools aren't a problem because we're not going to break them. Because we're managing the tools engagement, we can take a lot of material out of there very quickly. And of course, exotic materials are always tough on both. So again, the engagement angle of the tool is what really speeds everything up. However, you can use this in 3-axis positioning, or 5-axis positioning using 3-axis iMachining. So yes, you can. Like let's say you had blades and you're cutting a turbine. You said will, but if you're cutting an actual what am I thinking of, a fan blade or something like that, you can absolutely rough this out in 3-axis by doing it in not simultaneous, but in actual positioning. So that will be out with the next release. It doesn't do anything for finishing. Finishing is always small depths of cut, so there's nothing that we can do with iMachining for that. It's completely different technology. Does that answer your question, John? I hope so. Let me know if it does or not, or explain further. Okay, great. Could you illustrate face milling iMachining? I can do that, yes. Let's get through some of the questions and I'll jump back to that one. How do I get the material database like yours? Mine seems to have a lot less material listed with no plastics. Well, I'll tell you what. Send me an email, which my email address is at solidcam.com. This is send to all. By the way, I am videotaping this, not videotaping, I'm recording it. So if you guys want a copy of it, I can send that out as soon as it gets done rendering. Send me an email and just simply tell me whether you want the video, and if you want this tool database, I can send that out as well. Okay. That actually brings up another good question. Let me illustrate both face milling and the materials a second time here, because we didn't go over creating a material, and that is kind of important. So what we'll do, iMachining face is very easy. If we're going to cut this face, top of this part here, in fact, is this? Yeah, see the material's up a little bit, so yeah, we have some face to cut off. So I'm going to go ahead and create another iMachining operation real quick. For the facing, I'm going to simply grab this outside edge because I want to face the whole stock off, right? So we'll go ahead and grab that. Grab your tool, whatever tool you're going to use for face milling. Maybe you're going to use this face mill tool here. Levels. We'll start here. It's the top of the stock. And we'll go down to the face of the part. Technology, crank that up and run it. Now, if you didn't want just one pass, or if you just if you wanted just one pass, I should have marked that as open. Let me go back and do that. Haste makes waste. Right click, mark chain as open, select OK. Save and calculate. Now my toolpath should come out to the edges. There we are. And actually this should show us a little bit of our entry rate as well if we want to play with that. So that's basically facing off your part, which you can do, and a lot of people do use it. But this is your entry move it's referring to. That's the entry move we were talking about down here. It actually affects the overall straightness of your paths. If we take a look at this, and crank it down to 1. Notice how the entry rate here, it's more of a, I personally like it on a face milling. I like it up here because it gives it more of a smooth motion. But you can also mess with your efficiency as well. Let's see if we can get a little better here. That's efficiency 1. That's efficiency 10. So you can see how drastically it can affect your part. I think 6 is probably the best here. Entry rate, that's fine, 10. So that's all. You simply select your top edge, mark it as open edge, and it'll do your face milling. Let's go ahead and take a look at that actually. Now, of course, I can drag that up to the top and do it first if I want. Of course, we'd have to recalculate everything, but we'll just take this one, grab the icon, drag it up to operations, place it at the top of the list. Okay. Now, the material, that's what I wanted to talk about. Let's go back into the actual iDatabase here and take a look at the material. You were saying that how do you get material like this? This is an updated list of the material which will be available the next version. However, I will send it to you if you ask for it. Okay, but let's say there's a material in here that you don't have and you need to create. It's very easy to do. You simply select New, and this power factor here becomes a tensile strength. All material has a tensile strength, and it's based on foot-pounds, I believe. All material will have a tensile strength related to it. That's all you have to put in. Put in the tensile strength. There are factors in here, but again, this is for a more advanced day. When you really get into this and you're pushing your cutter, I can show you how to adjust some, like your cutting speed and probably your max cutting angle are the first two that I would play with first before doing anything more anyway. So to make a material new, give it a name, put in a tensile strength, and we'll take it from there. All right. Is this like trichordal machining? No, trichordal machining is a series of loops. What they do is when they encounter a corner, they start to make the tool just do actual circles. And what it does is it does help a little bit. When we do have trichordal machining, it's one of our advanced options that you can enable if you want. But the fact is it's still a big waste of time. But it does cut down on breakage of tools in the corners. So that's what the industry came up with a long time ago instead of iMachining, because they couldn't get iMachining to work or didn't know how to do it or didn't think of the concept, whatever. Trichordal machining had its place, but it's, in my opinion, completely obsolete now, especially in some systems where I've tested against, where it actually goes from climb milling to conventional milling. And I won't tell you the system. I'm not trying to blast anybody, but it broke the tool as soon as it did that. We put it down as deep as our iMachining, and we compared the tool paths. Not to mention that we blew them away as far as time goes. They actually also broke a tool as well, simply because it's not the best technology. It helped more than a traditional tool path, but was not effective enough. Let's put it that way. All right. I think that's all for me, unless we have some more questions. And like I said, please just shoot me an email if you want the recording. Okay, John, you got another question? Will this work with a 4-axis? Yes. And rotation? Yes. Let's see. I don't know if I can find that. I doubt I can find that part. Let me take a quick look. See if any one of these pops out at me here. I do have a 4-axis. I should probably put that in my, maybe I do. Maybe I have it in my, no, I don't, darn it. I'll have to put that in there. But yes, you can use it on 4-axis. I've wrapped it around, it was actually what they call a J-lock for the oil industry, and it worked beautifully. I even had, I had open edges I marked because I could do this in 2 positions because there was 2 J-locks on this thing. But yeah, it works really well. It's just as effective as if you're doing it in 2 or 3 axis. And yes, it'll work both in X and Y, depending on which way you have the rotary. Does that answer your question, John? And actually, I don't know. It looks like everybody's got for now. Well, here I'm gonna unmute you real quick. Go ahead and we should be able to hear you now, John. Are you there? Or maybe you don't have a mic. That's possible. No mic. Okay, got it. All right. All right. I'll just wait a little extra in case anybody else has any more questions. And Greg, I will get with Chris and I'll get back with you with an answer on that multiple finish pass cut. I might be missing something or they just haven't put that in yet, but it would be a nice addition. I agree that a spring pass is not a bad idea. Even though, you know, because we're managing the tools engagement, you're never taking too much material, so you should be pretty good after that finish. However, I've always gotten used to taking 1 or 2 spring passes, especially if I'm looking for a very accurate size on a wall. So I agree with you. All right, guys. Well, if there's no more questions, I think we're done for today. Again, please send me an email if you're interested in either one of those things or anything. If you've got more questions, go ahead and shoot those over as well. Hold on. Do you have benchmark data comparing pocket roughing with iMachining? Well, we could do it in here, but I have tons of data. I mean, I've got a whole folder over here. Let me just show you something real quick. Here's my email. If I go into my iMachining successes, every one of these, when they come in, let me just show you, every one of these is a true scenario, a true case, and it's not a fake thing, it's actual customers, and their feeds and speed gains on these. Let's see, the latest one was time reduction of almost 50%. Which one was this here? About a 95%. Oh wait, that's demos and booths. Sorry, that's something else. This one, they went from 60 minutes down to 3 minutes. By the way, you can look at email address. Oh, did that not go to everybody? Hold on. It should have gone to everybody, but here's the email address again. Send to all. You should see that. Hopefully everybody sees that, but there's my email address again. This is typical. These it seems outrageous, but 60 minutes down to 3 minutes we're seeing. And I always say that we do a 30%, a 35% minimum savings, but the fact is that it's extremely low. That was at another trial. There's a time reduction of 50%. All of these are true cases that have reduced their time significantly. This one went from 15 minutes down to 3.5, around a 75% savings. People are doing this all over the place. So if you need those, I can send you a couple, or better yet, you can go on YouTube, and customers are putting up their own stories because they can't believe it. Sure, Greg or Craig, I can do that. As long as it's not something huge that I have to program your whole part. You know, if it's a, you know, one toolpath, that's fine. Go ahead and send it over, and I'll take a look at it. So anyway, I think we're done. We've got definitely more questions than I normally get, which is good. I'm glad to see. If you guys are interested in actually seeing this live, let's see here. Calendar event. Let's see here. It's not on my calendar right now. Oops, close that out real quick. Normally we do webinars here. I haven't made up any of the past ones. This was the live iMachining last week, and I believe they're continuing this on Friday, so we'll need to get those. I don't have them listed here. So, but I would definitely check, because on the 4th, this Friday, I believe they're going to finish up where they left off with these two iMachining webinars here. This is actual live machining. It'll be done on the machine itself. They'll videotape it. I think he has new links here, otherwise I would send these out. I can ask for those, and if you guys are interested, I can definitely send it to you. All right. Oh, shoot. Where'd my questions go? View questions, there they are. All right. Okay. Oops, got another question. Wow, you guys are good. When helixing in with iMachining, what speeds and feeds do you see or do you use for helical interpolation? Another good question. I was looking for that a little earlier. I believe he has some feeds and speeds associated with that. Is it under technology? Or is it might be that it's on the new center drilling position? Ah. Well, it looks like it's using the same feeds and speeds. No, it can't be. I know it's not using the same feeds and speeds. You know what? I'm going to have to get back to you on that one, Tyler. I've had that question before, and I don't think I ever got an answer on it because I know it's using different feeds and speeds. Maybe it's possibly in here. There it is. Well, there's the helical speed it'll use. It looks like it's using the same spin rate. Feed helical, there it is. So you can change that if you want. You can change them both if you want, as a matter of fact. And that's right inside your tool data field. Let's see. That was your question, correct, Tyler? You want to be able to change that? This is why it took so long, 20 inches a minute. I know you can go faster, so. Are you looking for recommendation? Well, that depends on the material and the tool. The bottom of the tool matters. Generally, most tools have about a 3-degree relief on them, and some are not center cutting, others are. I do know that there are tools out there. They actually have a hole through them, and then there's actually a reverse chamfer on the inside where the hole meets the bottom of the cutter, and you can go down at like 15 degrees. Right now, I think, I don't know what it was. It was like 2 degrees or something like that. Where was that? Yeah, ramp angle, 2.5 degrees. The reason they do that is because the bottom of most tools are only 3 degrees. However, I can direct you to some manufacturers that create tools with a much steeper angle of it. It's not actually 15 degrees on the bottom of the cutter, but the way they create their geometry, you can go down 15 degrees without any problem at all. That's the tool I was using when I was testing the technology, drilling versus milling a hole, and we were able to helically interpolate a hole faster than we could drill it. That's how fast these tools work. Actually, I'm going to go ahead. I don't know if I should do this, but SwiftCarb is the name of the company that creates tools for iMachining style tool paths. Okay, and if you happen to contact them, you can let them know that Darren Bryant was the one that referred you. He'll know who I am, and maybe you can get an extra deal out of it. Let's see, we're looking for recommendations. Tyler, send me over your information, like what are you cutting, you know, steel and aluminum. Be specific, and then we can talk, and I can give you some recommendations. I recommend some other tools out there too, but if you're talking about helical interpolation, if you're trying to get into the material and you don't want to drill, I'm going to recommend SwiftCarb. Okay, but I do have other recommendations for other tools. The first one I started out with was actually OSG Blizzard, their little half-inch tool, an amazing little cutter, and it's only like $30 for a half-inch tool, I believe, and it's a fabulous cutter. So That was by OSG. Cut on a profile. I'm using a helical cut on a profile cut. Is there a way to get the cut to enter into the material faster? It does a 2/3 around the part before it cuts material. Oh, well, yes, that's that right here, the entry rate. Crank that thing up. It should jump into your part a lot faster. Has Ken developed his iMachining tooling any further, or any further, I think is what, any further? I'm not quite sure, Tyler, any further? I know he was developing something, but I don't know where he's at with it. I can certainly ask. If you send me an email, I'll ask him, or you can send him an email directly. I know he's out this week on a training, so. Oh, no problem. Again, guys, if you have any other questions that we don't cover over here, or you just want more general information, you can give me either a call or an email. Generally, I'm pretty busy. I do most of the trainings and almost all the demos, but I always get back to you, but it'll be in between those times, and generally my demos and trainings last 2 hours at a time. So, all right, guys, I'm so appreciative that you guys were very into it. I mean, you guys asked a lot of questions, and I'm glad to see that. So, all right, guys, I think we're done. Please send me an email if you want the video, and we will talk to you guys soon. All right, you guys have a great day. Bye-bye.